Hello friends, welcome to Input Output Campus. Today in this video we'll see another bit manipulation problem, and here's the problem. Check if the ith bit is set in binary form or not. So you will be given a number n and I is the ith bit position. Okay, so you have to check if in this number n in the form of binary ith bit is set or not. Here n equals to 20 and I equals to 4. So first we'll convert the number n to binary. Then we'll check if the ith bit, that is the position 4th bit, is set in the binary form or not. If this is set, then we'll output it as yes, and if it is not, then we'll output it as no. Okay, so this is the problem, and let's see some example here. So here n equals to 20, so here n equals to 20, and if we convert this 20 in binary form, then it will be like 10100. Okay, so this is the binary form of 20. So the index will start from the right position. So our I value, that is the index value, is 4. Okay, so 4 means this is 0 position, this is 0 position, this is position 1, this is position 2, this is position 3, and this is position 4. That is, this is the ith position, 4th position, and the bit is set. So bit is set means the bit is 1, and bit is not set means the bit is 0. So our 4th bit is 1, that is this bit is set. So the output will be yes. So if it was 3, then 0, 1, 2, 3. So the 3rd position bit is 0, that is the bit is not set. So then the output will be no, that is the bit is not set. So now how we can solve this problem? So this is very easy to solve this problem. We can solve this problem in just writing a single line of code. So in the previous videos we have learned the left shift operator and the right shift operator. So we'll use that concept here. So if you not know about the right shift and the left shift operator and how to use that, then please watch the previous videos. There I have explained you in a very easy way how to use the left shift and right shift operator. Okay, so let's write here 1 left shift 2. So 1 left shift 2 means 1 into 2 to the power 2, that means 4. Okay, so if we write here 1 left shift 3, so 1 left shift 3 means 1 into 2 to the power 3, that means 8 here. So now if we write 1 left shift I, then it will be, okay, this is I, then it will be 1 into 2 to the power I. Okay, now our I value is 4 here. Okay, so we'll write 1 left shift 4. So 1 into 2 to the power 4, that is 16. And the binary representation of 16 is 1 0 0 0 0. Okay, so this is the binary representation of 16. Now we will do the AND operation between this n and 16. Okay, and what will be the AND operation? And the value of n is 1 0 1 0 0 and 1 0 0 0 0. Okay, so if we do the AND operation between these two numbers, then you can see the 4th position number is similar. Here the 4th position number is set, and here also the 4th position number is set. So if we do the AND operation, this will give us true or false. So here the output will be true. Okay, so after doing the AND operation, if the output gives us the true, then it will be, then the ith bit is set. Okay, so if n and 1 left shift I, if n and 1 left shift I is equals to true, then the bit is set, that is the ith bit is set. Okay, so this is the main thing, this is the formula. So let's write the code here. So here we have write the basic format of the C++. So first of all we have write the main function, and inside this main function we will write two things, the integer n and I. Okay, so we'll take the input from the user. So for that write here scene n and I. Okay, so just take these two inputs from the user. Now we'll write this formula. Okay, so this formula. So for that right here, if n and 1 left shift I, so if n and 1 left shift I is equals to true. Okay, so if this is true, then we'll output it as cout yes. So else we'll output it as no. Okay, so this is the code and let's run it. Okay, there is an error in line number 9, true was not declared in this scope. Okay, here the true keyword is not present, so let's remove this. Okay, but there is another problem here, that if we check for I equals to 4, that is if we want to check n equals to 20 and I equals to 4, so if you want to check the position 4 and the index is starting from 0, okay, so for that you have to give here the I value is 5, and then here you have to reduce the I by -1. Okay, so here will be I equals to 5, that is 5 minus 1 equals to 4. If you want to check the position 4, then you have to write here 5. Why you have to write here 5? Because the index is starting from 0. The index is starting from 0. So 0 and then 1 and then 2 and then 3, 4, 5. Okay, so if you want to check this position, this fourth position, then this is actually 5, because this is 1, 2, 3, 4 and 5. Okay, this is 5 position, so you have to write here I equals to 5, and then we'll reduce the I value as I minus 1, that is 5 minus 1 equals to 4. So 4 means this 4, and the index is starting from this 0, that's why we have write here I minus 1. Okay, and I hope this is clear. And now we'll check. Okay, it's compiling. Okay, there is an error in line number 10. Okay, line number 10. Okay, in line number 9 there will be an extra bracket here. Yeah, so let's run it again. So give here the input as 20 and 5, and you can see our output is yes. So if you see here for n equals to 20 and I equals to 4, so I equals to 4 means the index starting from 0. So if you want to see the position 5, that is this position, for this position, so I equals to 1, 2, 3, 4, 5, then you have to write here I equals to 5. Okay, so for these inputs the output is yes. So here you can see this is 20, and we'll check 1, 2, 3, 4, this 4 position, this 4 position bit is set or not, and you can see that this is not set. So let's check it. So let's write again, and n equals to 20 and I equals to 4. So no, that is the fourth bit is not set. This is the fourth bit and this is not set. So let's check it for this third bit. So this is 1, 2 and 3. This third bit is set, and let's check it again. So let's run it. So n equals to 20, and we want to check it for position 3. Okay, yes. So the third bit is set. So this is very easy problem, and this is very interesting, and you have to remember these small things, because these small things will help you to solve the bigger problems later. So you have to know these basic things of the bits manipulation. So hope you enjoyed this video, and if you find this video helpful, then please share the video with your friends. Okay friends, so thank you for watching this video. See you in the next video. Till then, take care.